Today we're going to learn just about the addition and subtraction of polynomials, but like I said at the beginning, we need to go over a little bit of vocabulary before we really get started. Did you not get one? So let's define a polynomial. A polynomial is a monomial or a sum of monomials. So you'll see a bunch of polynomials all over the place. Like if you look at the bottom, there's 3 examples here. Okay. Notice how each one of these consists of like a sum or a difference of terms. So like this one has 1, 2, 3, 4 terms. This one has 1, 2, 3. This one, number 3, has 1, 2, 3, 4 terms. So this one has 4 terms, this one has 3 terms, this one has 4 terms. But they're just either adding or subtracting these terms. And the whole thing is called a polynomial. So each monomial, that's like those individual terms, is called a term of the polynomial. And so we're going to have like different names for polynomials that have different numbers of terms. So like if it just has one term, it's a monomial. So monomial is one term. If you have a polynomial with 2 terms, it's called a binomial. Just like a bicycle has 2 wheels, a binomial has 2 terms. A polynomial with 3 terms, you might be able to guess what it's going to be called. Trinomial. Yeah, exactly. And anytime you have more than that, if you have 4 or more terms, you just call it by the number of terms. So like you say like a polynomial with 4 terms. It doesn't really have a fancy name. So if you have 4 or more terms, then you say it's a polynomial with however many terms. So number of terms. Just however many there are. So here's an example of a binomial. Notice we've got 2 terms that are being added together, 5x plus 2. A trinomial has 3 terms. So we have like x squared plus 5x plus 2. So we can classify all these polynomials like that based on how many terms there are. There's another way we can describe them as well. But before we get to that other way of classifying, there's a few other things I want to show you. So after you write it in what's called standard form, which basically means you write each term in order based on their exponent, so like 3, 2, there's an implied 1 here, and then 0. If you write it in that form, that first term, this one right here with the biggest exponent, is called the leading term. Okay? That leading term has what we call a leading coefficient. So basically it's the first coefficient of the term that has the largest exponent. The exponent or the largest exponent that's in the polynomial, we call that the degree of the polynomial. And finally, the last term is the constant. What's also kind of interesting about this constant is regardless of how many terms you have, if the term that does not have an x, that's also your y-intercept. That's something that'll come up later. All right, so I said there was one way to categorize these polynomials, by the number of terms they have, like monomial, binomial, trinomial, etc. But we can also categorize these polynomials by their degree. Okay, the degree of the polynomial is the greatest degree of each of the terms. So each of these terms, like this is a degree 3, degree 2, degree 1, degree 0. But whatever the biggest one is, that's what we say is the degree of the overall polynomial. So it sort of like trumps everything else. If you have a constant, like you don't have an x on there, then the degree is 0. So constant, degree 0. Linear is degree 1. Quadratics, degree 2. Cubics, degree 3. A polynomial in one variable is what we call in standard form when the exponents decrease from left to right. So in other words, if it's not already written in that order, you want to change the order so that it's written in standard form. And it makes doing a lot of what we're going to do a little bit easier. When you write the polynomial in standard form, the coefficient of that first term is what we have labeled up here. It's the leading coefficient. So let's practice just like writing these polynomials in standard form. We want to identify the leading coefficient and identify the degree. So like which of these terms should come first for number one? Yeah, and the other thing to keep in mind is you want to take whatever sign is in front of it, plus or minus, and keep that along with the term. So we're going to write the 7x to the fifth first, but we're going to keep that negative sign with it. So we're going to start with negative 7x to the fifth. What would be the next term? Yeah, 4x squared plus 6x plus 9. So notice 5, 2, 1, 0. So if the degree of the polynomial is whatever the largest exponent is, what's the degree of this polynomial? Yeah, it's a fifth degree polynomial. What is the leading coefficient? In other words, what's the coefficient of the leading term? Yeah, negative 7. Good. So right now we're just sort of identifying these values so that later on we can talk about what the significance of those numbers are. So number 2, what term's going to come first? Yeah, y to the 6th. So you have y to the 6th plus y squared minus 3y. What's the degree of this polynomial? So the degree is 6. And what's the leading coefficient? In other words, what's the coefficient of this first term? What is the coefficient of any term when you don't actually see a number in front of it? 1. So the leading coefficient's 1. For number 3, what's going to be the leading term? X to the fifth. And actually, once you identify that leading term, you can answer the follow-up questions without really getting the rest of the polynomial right. You know, like what's the degree going to be? 5. And what's the leading coefficient? 1, right? Okay, so you can do that right as soon as you identify the first term. So yeah, x to the fifth plus 9x cubed minus 4x squared plus 16. So this is the standard form. And then we're going to start classifying these polynomials based on their degree and leading coefficient. So I'm going to throw a bunch of more vocabulary terms at you. Now, you do need to know these, but we're just going to start using them so frequently that I think you'll pick them up without having to just like sit down and memorize all of them. But let's run through sort of the important ones. So there's 2 ways we can classify these polynomials. We can either classify them based on their degree, you know, that highest exponent, or we can classify them based on how many terms they have. So like how many of those things are being added or subtracted. So let's start with the degrees. If it's a degree 0, that means there's no x. Okay, so there's no x. We call that a constant because there is no variable. The number is just what it is, like it's 5. Right? So it's just a constant value that doesn't change. A degree 1 is just a single x, right? So like if you don't see an exponent on there, it's just an x. That's a degree 1. We call that linear. So for the whole first semester, what we looked at were equations that were linear, right? They were like in the form of mx plus b, like 5x plus 7, right? So that would be an example of a first degree polynomial, a linear polynomial. What we're going to get into after this unit are quadratic polynomials. Those are degree 2. So that's if you have like an x squared. Degree 3 is when you have like x cubed. That's going to be a cubic. Degree 4 is when you have x to the 4th. Degree 5, x to the 5th. Those are going to be quartic and quintic, respectively. And then if you have anything above 5, we sort of run out of names. And so we just say, oh, it's a 6th degree polynomial or a 7th degree polynomial or whatever it happens to be. We can also classify these polynomials based on how many terms they have. So that's sort of what we led with. If it's just one term, that's called a monomial. 2 terms is a binomial. 3 terms is a trinomial. And then if you have 4 or more, again, we sort of run out of names, like specific names. So we just say it's a polynomial with however many. I'll just say, if I call this n, I'll say n terms. So if there's 7 terms, you just say it's a polynomial with 7 terms. Let's take a look at some of these polynomials. Okay, so we want to classify them based on their degree, and their leading coefficient, and their number of terms. So first of all, let's start with like what we don't really classify these as. Let's start with the leading coefficient. So what is the leading coefficient of number 4? 5, right? What's the degree? 3. And how many terms are there?
2.
So, okay, so the two things we're actually going to classify it on is the degree and the number of terms. So you start with classifying it based on the degree. That's your adjective. And then you classify it based on the number of terms. That's your noun, if you're like, thinking in terms of English, right? So there's a description and then like what it is. So if we classify it based on the degree, we call it a cubic. So it's a cubic. And then what kind of polynomial is it? Binomial. So we call it a cubic binomial. Number 4. What's the leading coefficient? 4. Okay, that's 4. What's the degree? 6, good. And then how many terms are there? 1, 2, 3, 4. Okay, so again, these are the two things that sort of matter in terms of answering this question. But I'm going to keep asking about leading coefficient just so that we don't like lose that term. Or vocabulary word. Okay, so it's a 6th degree, so we don't really have a name for that, so we just call it a 6th degree. And then how do we classify it based on how many terms they have? Binomial. So 6th degree binomial. Wait, not a binomial. What are we talking about? Yeah, so it's a polynomial with 4 terms. So this is like one of those that just like doesn't have a convenient name, right? You just say what's the degree, how many terms does it have? All right, what about this last one? What's the leading coefficient? -2. What's the degree? 1. And the number of terms? Just 1, right? So if it's a degree 1, we say it's linear. And the number of terms is just 1, so it's a linear monomial. All right? So let's get into adding and subtracting. This is going to be the easiest part of this unit, because really all you're doing is just combining like terms. And you've done that before, right? We did that a lot in the first and second units. So I think the easiest way to kind of go about doing this, particularly with the addition, is to rewrite the problem where you have the polynomials kind of stacked on top of each other, and you have the like terms lined up. And just to remind you, when I say like terms, I mean terms that have the same degree. So like, line up your quadratic terms, line up your linear terms, line up your constants. And then when you go to add, you just add each of the columns individually. So like if I want to work this one, I'm going to write 4m squared plus 5, and I'm going to add m squared minus m plus 6. Notice I left a little bit of space here because that first binomial does not have a linear term, which is fine. You just like sort of leave it blank. Or one way to think about it is you could say like plus 0m, right? It's just a missing term. So then I just add my columns. What's 4m squared plus m squared? Yeah. So when you're adding like terms, you don't actually change the exponents. 4m squared plus 1m squared is just 5m squared. If you were multiplying them, the exponents would change. But just adding them, no. So here we have like 0 plus a negative 1. So what's 0 plus negative 1? Yeah, negative 1, right? So minus m. And then 5 plus 6, 11. So that's our result. And now let's classify it. Okay, what's the degree? 2, so it's a quadratic. And then how many terms are there? 3, so it's a trinomial. All right, cool. So let's do, all right, so number 8. Notice we have some terms that have xy. So those are like terms, as long as they both have xy. So if I'm adding these together, I've got 10xy plus x, and then I've got plus negative 3xy, and then I have this plus y. That's not going to be a like term with x, so that's going to have like its own column. All right, so let's see. Ellie, what's 10xy minus 3xy?
7xy.
Right. And Ari, what's x plus nothing? X. And Dana, what's nothing plus y? Y. Good. So here's our result. All right, now this is going to come, we've come to a point where we've got a term that actually has multiple variables in it, and this is not something that we've seen yet, right? Is how do I classify something like this? Because when we talk about degree, usually we're just talking about the exponent. But really what we're talking about is how many variables are being multiplied, right? So if I have something like x cubed, like x to the third power, you say, oh, it's a degree 3 because it's x times x times x. Now there's 3 x's being multiplied. But the variables are different. You still sort of count them in the same way, but you sort of pay less attention to the exponents, right? So what I'm saying is, since we have 2 variables being multiplied in this term, then the degree of this term is 2. Does that make sense? So, like, if I have, as just sort of like a side problem here, let's say I have like x, y, z. What would that degree be? So that would be a third degree term, right? A cubic term. What if I had something like x squared y? What would that degree be? how many total variables are being multiplied there? So I've got x times y. So there's actually 3 of them, right? So it's like you actually have to count up all of the variables. So like if I have something like a to the 4th times b to the 5th, what's the degree on that one? 9. Okay, you guys starting to see? So this only comes up if you've got more than one variable inside of a term, which won't be often, but it will come up from time to time. So like, let me show you an example of a problem on your homework, okay? So when you get your homework, you'll see this one. So like the first section is saying, find the degree of the monomial. Just what's the degree? So like, what would the degree of this one be? Let me zoom in on there for you. So this is a 6 degree, right? What about this one? 7 degree. Okay, so I just wanted to point that out. That's not going to happen very often, but it does come up. So yeah, since it's a second degree polynomial, we say it's quadratic. And then how many terms are there? 3. So it's a quadratic trinomial. Now you don't necessarily have to like stack them up. I just think that makes it easier. Like if you can just like look and sort of like add up the terms as you see them, that's fine. Now number 9, there's a little something different happening, and that's because we can actually simplify this second polynomial up front. There are some like terms that haven't yet been combined. So like, what is 3x squared minus 8x squared? So it's negative 5x squared. And then we've got 3y minus 2y is what? Yeah, 1y. So just plus y. Okay, now we're ready to start stacking. You only want to stack the like terms on top of each other. So we've got 6x squared, we've got a minus 4y, plus negative 5x squared plus y. So what's 6x squared minus 5x squared? Yeah, just 1x squared. And then negative 4y plus y. Yeah, minus 3y. Good. So x squared, what would that be? Oh, I forgot. I'm supposed to be calling. Is it? Ruby. How do we class? So it's second degree. So what do we call that?
Quadratic.
Quadratic. Good. And based on the number, first of all, how many terms are there? 2. Okay. So Mason, how do we classify based on the fact there's 2 terms? And feel free to look back in your notes if you don't remember. Binomial. Good. So like the number of terms, you can kind of think of it like the number of wheels, right? So like your polynomial is like a bike. If it's got 2 wheels, it's a binomial, right? If it's got 3 wheels, it's a trinomial. If it's got 8 wheels, it's probably not a bike anymore, right? But all right, good question. So all right, let's look at a subtraction problem. So subtraction is just a little bit harder because what you have to do is remember to subtract each individual term. So as a way to make this a little bit easier, what I typically suggest is that instead of trying to remember to subtract, turn it into an addition problem. And the way we turn it into an addition problem is we distribute this minus to each term in the second polynomial. So I'm going to rewrite this as negative 10x squared minus 3x plus 7. Nothing changes there. But I'm going to change this to an addition problem and write this as negative x squared plus 9. So you're basically just flipping all the signs in the second polynomial. Then you could just stack them and add them like you did in all the other problems. So we've got 10x, or negative 10x squared minus 3x plus 7 plus negative x squared plus 9. And so now I don't even have to worry about the subtraction. Just kind of, worrying about subtracting negatives, like that's usually pretty messy. This works a little better. So we got negative 10x squared plus another negative x squared. So how many negative x squareds are we going to have? Yeah, so negative 11x squared. That minus 3x doesn't have anything to combine with. And then we have 7 plus 9 is what? 16. So the key thing that I want to point out about that one is this: when you have a subtraction here, it's just to distribute that negative and then add. It's probably the easiest way to do it. So let's see here. Andrew, what's the degree of this polynomial? 2, right? That's the largest exponent. And let's see here. Juliana, how many terms are there? So careful. There's 3 of them, right? Okay, so it's a second degree polynomial with 3 terms. So Bella, how are we going to classify this? So it's quadratic, good. And yeah, whoever said that is correct. Yeah. Who said that? Yeah. James? James? Good job, James. Yeah, it's a trinomial. All right, we'll just have a couple more, and then I want you to practice on your own. Okay. Number 11. All right, so let's see here. Stefano, for number 11, notice it's a subtraction, right? What do I need to do with this minus to change this to an addition problem?
Make on the second side,
Mm-hmm.
make the first 5m negative.
Right. So I'll make that one negative.
And would I change the plus to a minus, or?
Yep. So basically, all of these terms, you're going to change the signs. So you're essentially going to distribute that negative sign. So I'm going to rewrite this as 7m to the 4th minus 2m squared. Now I'm going to change it to a plus and distribute that negative. Negative 5m to the 4th, and then plus 5m squared, and then minus 8. Now I'm ready to just kind of stack and then add, right? So I've got 7m to the 4th. I'm going to leave a little bit of space. Actually, I don't really need to leave space, right? Because neither one of these has a m cubed. So minus 2m squared. I'm going to add that to a negative 5m to the 4th plus 5m squared minus 8. And then just add your like terms. So 7m to the 4th plus negative 5m to the 4th be 2m to the 4th plus 3m squared. And this has nothing to combine with, so just minus 8. All right, y'all help me out. Now this one we haven't really done too much, a 4th degree. What do we call a 4th degree polynomial? Quartic. Yeah, that's kind of sort of a weird one. So it's a quartic. Oh, I heard someone say it. Yeah, what was that? A quartic trinomial. Oh man, you guys are good. By the way, what's the leading coefficient here? 2. Good. Okay, good. Yeah. All right, last one. All right, last one. We need to distribute that minus. And then let's rewrite it. Okay, now we're going to stack them up. 2x squared minus 3x squared. Oh, wait a minute. Did we forget something? We did forget something. What do y'all notice about that first polynomial? Yeah, we didn't combine the like terms, right? It's not in standard form yet. So what is 2x squared minus 3x squared? Yeah, negative x squared plus 1. So just be careful about that. That might, now you should catch it like I just did. Like if you're not really paying attention to that and you just start writing the terms out, and you say, wait a minute, I've got 2x squareds here. Like those should have been combined. Like when you're creating your columns, you shouldn't have two columns that have the same degree. It should all be different. So we've got negative x squared plus nothing, right? And I'm going to actually leave a little bit of space because I do have a linear term on this next one. Plus 1. So that's the first one. Now write the second one. Negative x squared minus x minus 1. Add these together. So my result is negative 2x squared minus x, and then what's 1 plus negative 1? 0. So you don't have to write the 0. Just leave it blank. All right. Anyone want to dare try to classify this one? Yeah, give it to me, Aiden.
Quadratic binomial.
You got it. Quadratic binomial.